Hey everybody, this is Brad Dyke saying hi. And today we are going to do something special. What we are going to do specifically, let me flip the camera here, is we are going to talk to this. Now down here on the floor is my dual Xeon workstation. It's been a great chassis, I'll go over that in a few minutes. But I have purchased a new Xeon dual base server chassis. It's basically just a generically enhanced full tower. It's called an Enthoo Pro TS TGPH ES614 series chassis, and it's pretty nice. As you can see there, the manufacturer of it, Phanteks. And overall, the box is pretty large, and it is a true, genuine full tower. And it's right here, as you can see. And this is going to house my new case for my dual Xeon. So this is my dual Xeon. It's a super micro dual CPU motherboard with two V6224 series version Intel Xeons. And these are 24 cores each, giving me a total of 48 cores. And if you look down below, you'll see that it's got some age to it. Now, those are industrial fans. Those are not PC fans. You don't buy PC fans. PC fans look like that right there. And that's a replacement fan, by the way. And I've got my built-in environment, and I've got my NVMe right here, and my RAM capacity and so on. But all in all, this is not quite a full tower. And what do I mean by that? Because this is a full tower. Okay? And then you look over here, it's not. And if you look at the back, you can see the availability and setup. And then over here, you can see in this environment a under panel section which I took off, and the comparison of the thickness is wider, as you can see here, as well as adaptive for other configurations compared to the width of my existing footprint here. As you can see here, it's pretty slightly thinner, slightly shorter. It's mid tower / almost full tower. Now, something I'll point out here is you have a cable management platform here, which is designed to give you the peripheral interfaces that you want. Plus, it also has a fan distributor, and at this time there's only 2 active distributors in place, which this goes out to the CPU down there and splits that power across multiple fans. And as you can see, also I have the availability of doing a lot of hard drives, all the way down to here, basically, a total of 8 drives. And over on the other side, if I take the threader screw out, this is tempered glass, so you can see clearly, but it'll also keep the dust a little bit better under control, because obviously, as you can see in my old chassis, dust is a challenge because of my dog. I love her to death, but still, things are what they are. So as you can see in here, you get a box. You get your own specialized set of screws, and you have replacement bolts and screws for key screws like this particular type of unique screw, which bothers me a little bit because as you look at it, you'll see that it is kind of unique opposed to a more traditional screw like this. But that's okay. And so with this being the case, you get the screw sets. They give you some Velcro and zip ties. And for once, you actually get a real by God manual that actually truly talks to the nature of how your unit is to be set up. Now it also has a case housing designed to deal with water cooling, but also designed to handle air shift and control. And not only that, it also has an underbay filter, which to me, working in data centers, using positive charging effects for day filters, that's okay. I mean, it's fine. You can do that, but it's located down here, and I should be able to pull it out. There it is. And, it does a positive charge, static discharge, which is supposed to help catch dust but it will help to keep it under control. Now, the one thing I do worry a little bit is they didn't weight this very well when it's on its own. So when this door opens, the door is significantly heavier than you would expect. So because of that, it's advantageous to secure the door until you've got your power supply and a few items in there to balance it out. But all in all, as you can see, they are not the same. So I'm going to enhance my setup in this chassis, provide all the feature functionalities I want, plus I'll be adding some additional venting controls in, and I'm also going to probably relocate this very powerful, very functional fan once I clean it up. But we'll be talking to all of this tonight. Okay, so to begin first, we are going to build ourselves a static, basically create what's called a static discharging effect, where we are going to basically go through the process of clearing this table and using anti-static bags to handle the motherboard, to handle the electronics that are all important. I don't want any of them being damaged. Though electronics these days are a heck of a lot more durable than the older days, still you want to take precautionary steps. Plus, we're also going to take some time to do some cleaning and to make sure that we have the ability, just kind of cleaning stuff up as we go along and depopulate it. Now, eventually, once this unit is completely empty, this case is empty, I will wash it with water. Yep, water. I said it. And that's perfectly okay, because it's just basically a metal housing. And by using water, it really does help clean up the environment. So we've got the static discharge bags here, and we're going to basically just do a quick mass emptying effect of this environment. We'll be using the box over here to holding recursory stuff, which is not critical. And that's okay. That's not a problem. We'll just put it in there for now and sort it out later. So as you can see, I have a fairly sophisticated power supply in here, but its fan is also pretty nasty looking. So I'm going to clean that up as well to get it to a fairly healthy place, just to at least get rid of the dust. So we will work with that. Now remember, when you're dealing with dust, best to take the components away from the chassis, dissipate away from you, of course, and to use inert gas as much as possible. What do I mean by inert gas? Okay, this is basically inert gas. We're looking at dust off. It's electronic safe. It's an inert gas compound designed to not promote static discharge. And that's what we want to make sure we're avoiding, because this is a plastic surface, but since I have grounded out the actual chassis itself, and the chassis is now making contact with the static bags, that's going to maintain a place for that discharge to go, and so there should not be a buildup. Now, depopulating a chassis also won't put much risk to your electronics unless you do something dangerous like grab an electrical wire and something like that. But outside of that, we will begin this process of taking all this out, and I'll be putting my trusty tripod here to do a down angle, as you can see as we're removing the parts and pieces and how I'm handling them to help you be able to learn how to handle your own stuff. Okay, so now we've got the camera in place. You're able to see all the peripherals here for the most part. I'll put it at a slight angle so it's a little easier for you to see it. Here you've got the video card, and they've got nothing beyond this point, so hopefully that's not going to be a problem for visibility wise. You've got your I/O card, which is down here, which is our NVMe card. You've got the CPUs, and the motherboard, the peripherals, and a power supply, and then eventually the fan assemblies of the case itself, which I removed the fan assemblies because they're going to be required to be cleaned, and you don't want to have electrical motors inside a case when you're going to use water on the case to clean it. So with that being the case, we will be first getting ourselves some key tools. And these tools will be designed to basically depopulate the chassis. Now, the cool thing about these tools, you recognize them. They're not that fancy. One's a ratchet, one's not. It's a Phillips screwdriver. And then is also, because you're depopulating, you can actually use a micro drill like this. Not the drill. The drill bit comes out. But it's for the hex nut sets, and I'll show you the hex nut I'll use to help speed things up. Okay, so this long neck screwdriver can be put into the drill, and it will basically provide me the ability of going in and extracting components pretty quickly. That's the good thing about this. It's fast, it's variable, which is important. And the key secret here about this, and let me explain this clearly to you, because it's a very important detail. You need to understand that if you're unscrewing components, you can use a drill. When you're putting a component in, you have to use a screwdriver. Remember that detail. It's very important because you will strip the screws if you drill them into the board. But yes, you can very quickly depopulate them if you're just removing the bit. So I've also got some special bits here, and right here and right here. So I'm going to get some kit here for me. And what I'm going to use is my Mac Hex kit. And this is pretty cool. My son got this for me. Yes, it's overkill. But as you can see, it's got every single solitary version, and it's industrial quality too. So these are going to be around for a while. This is really good because in some cases you're going to find screws on your case that are not Phillips or standard compatible. So what I usually do before I ever start this kind of stuff is I will first tight match the proper bit I need, so I can take this out. That's not it. Let's see here. All right, we got it. So now I'm going to put this guy on, and whenever I have a special bit requirements that I have to do that with, I'll use this guy to take them out like such. Hard drive screws are usually like this, and it's usually a little pragmatic of an issue. But with having these kind of bits, you're not going to have that problem. Now, something else to remember. I'd say about 2 years ago, I told everybody, go out and buy yourself a dual Xeon motherboard with PCIe 3 bus, and you will love it. And not only was I right, but heck yeah, I was right. Because I was able to get a motherboard that was far superior than an i7 or an i9 or an AMD. And I have extra firepower, so I can play games, I can run databases, I can do VMs all at the same time. And you're on a motherboard that's designed and architectured for advanced functionality. That's why I always said back then, if you can get a cheap Xeon motherboard, get it. The processors come out cheap too. I bought my two 24 processor stacks each for $24. Those were $2,500 a pop when they were brand new. And I got them for $25. 5%. That's pretty doggone good. So that's why my core is a Xeon environment. Now, also I have to use a Linux environment to take full advantage of my cores and my memory where Windows can't. So when you step away from a single processor environment and you want to do something more, this is the direction you want to go. Now, as you can see, it's pretty dense in here, but the airflow is very clear. We have the airflow feed here, the airflow exit out here. We're going to do something very similar to this in the new case, but the new case will actually let me have more airflow than this case has, and that's an important detail. So we're going to first start by taking off the restrictor bolts of the drives. Now, unfortunately, I have two DVD burners here, Blu-ray DVD burners. So the problem with that is that I don't have the ability to, how would you say, properly use them in the new case, because the new case has only 3 bays. Now, a problem you're going to find out is that if you are a true advanced person, right? In other words, you're doing some pretty fancy stuff. Maybe video editing, maybe some device editing, hard drive work, stuff like that. Then you need bays. And manufacturers are trying not to provide you bays. They don't want you to do that. They want you to have a tower that just is, that's it. It's just a tower. It has no functional front on it that is of any value. By the way, if you use something like this, it catches your screws so they don't go wandering. Very valuable. So the end result is I have 4 devices in this chassis that are peripheral devices in my system, and they are, I can't transfer them all. That's the problem. Now, what do I mean by that? Basically, in a nutshell, what I mean is that as I pull these drives out, i.e. my first DVD burner, this device is, one of these is going to have to give up the ghost, basically. And so, you know, I have some pretty sophisticated equipment here, which I'll show you what those look like in a second. I have to first have to depopulate them correctly. Let's see, what else we got? Oops. I popped that off. Nope, I did not. Okay, so here's another one. But this one's got a thin Blu-ray burner right here and 2 2.5-inch drive bays. Okay? Now they're not populated right now, but when I do hard drive work in some of my videos, I use these rapid deployment chassis housings, as you can see here, and you can see the dust on it, to quickly stage SSD drives based on whatever I want to use them on in the case of configuration or formatting or disk repair or disk transfers. The biggie is disk transfers. I'll stick in 2 drives side by side, and here's another one. And this one has 2 sets of drives in it. And I do recommend that when you're taking things out like this out of your system, you always make sure that there isn't something in them. And that's very important, because if you look, there's not. And these guys can be then properly and summarily put off to the side. So my chassis could and was able to do quite a bit. But something else I have very important on this is, and you can't see it right now, but is a thermostat and USB and multimedia kit. In other words, it's right over here on this side, and it's got SD card slots, it's got USB 3.0s, it's got a thermostat controller, it's got fan controls, and so on, which currently intersect with the motherboard. So that cannot come out, unfortunately. So with that, now what I'm going to do is I'm going to prepare to remove my cards from use. And what I'll do there is I'm going to take the video card out first. First I'm going to depopulate the power connectors. And then what I'm going to do is, using a screwdriver, I'm going to remove carefully the bolt that's holding it in place. Remember, you don't want to lose these bolts. They'll go down on your motherboard and they can potentially do damage. So you want to be very careful on that when you're handling it. But there is my 3080 video card, and I'm going to put it over here on the open tray side. And as you can see now, here's the NVMe card. This is the heartbeat of my machine. It's got my boot OS on it, the very one that I use to publish these videos. So it's an important detail not to, lose this guy or damage him in any way, shape, or form. And again, I'm going to carefully put a screwdriver to this and secure that, because that bolt right there is very much able to damage a lot, which you have to be very careful with. And then I'm going to take out my NVMe card, and there she is. And I can put a SATA bridge card in here if I want, but that's not the same thing as the NVMe. Don't make that mistake. SATA's NVMe is not NVMe. It's slower by far. Now, what you can see now is my motherboard, the CPUs, the coolers, the fan ventilation controller here, which is right here, and I'm going to go ahead and decommission him. He's just a direct power. Take that guy off and depopulate him. Okay, so he's out. And I've got another fan here that is hooked up as well. And I'm going to start breaking off these connections. These are jump splicers. And start isolating the power cables so I can start to separate them out. And I have a lot of extenders and splitters and so on because I have a lot of gear inside this chassis. You know, so for instance, I've got these J-Hicks splitters here as well as SATA outputs. Now these are the cables I'll set aside for now. Other cables which I have, which need to be addressed, are the ones that are basically handling the data connections for the SATA drives. And so I'm starting to pull the cable feeds out. And there's another one. And these are coming out because I want to be able to clear everything correctly. Now, something else I recommend that should be done as well, and it's not always done so well, is that when you are disconnecting things, like for instance your motherboard connector edge down here, you want to make sure that you're tracking these pinouts, okay? So these pinouts are the ones that will hook up to the display screen. I'm sorry, not the display screen, but the front panel buttons, so that you can turn power on and reset and lights and LEDs and all of that good stuff. So we want to make sure we clearly identify those. You know what they are because we're going to have to connect to them again. And they're going to be connecting by a different way. So now I'm pulling all my SATA cables out. I had a lot of SATA drives. Alright, I've got two remaining SATA drive cables that belong to the case. So at that point stage, now what I want to do is I'm going to go after the rest of my power connectors. And I'm going to pull my master power out. Done. Okay, so that's off. So now my motherboard is, for the most part, exposed. I have two cables here. One is the one is for CPU fan 1 and CPU fan 2. And then I have a blue SATA cable, which I'm disconnecting now, for the CD-ROM drive. Then what I'm going to do next is I'm going to hunt down my fan controllers. In this case, my fan controller is this guy. So I'm going to pop this cover off for a second. All right. Whoa, whoa, whoa. That came off way too easy. All right. So as you can probably look over here on the side, you'll see that I have taken off the side panel. And the goal was to expose the front panel section so that I can start to depopulate that. Let me show you what that looks like. It's pretty yucky. See how yucky it is? So there's the media inserter there. There's the multimedia and thermostat controller there. And this is the fan assembly, which I'm going to remove. And I'm going to probably recycle that same fan into the other system because it's a very powerful, high RPM, high air mover style setup. And we want to definitely take advantage of that. So let me put this back over here real quick. And so I will take the steps of removing this guy. And this is where my drill comes really handy. Especially if I have the right bit in it. Right? Okay. Now if you look, This is just a standard screw. It's not what we call a fan screw. That's important because this is not a normal fan. This is an industrial server equivalency fan. And the sweet thing about them is you only need two. That's it. Either two on the top or two on the bottom, and it holds. And it does not take names. And this is the fan I'm talking about. It's a very nice style fan. And even though it's kind of yucky right now, I'll definitely clean it up like brand new and put it back into use. But for now, I'm just going to set it to the side. Now I'm going to pull all this off. Look at that. Yep, that's human skin, animal hair, you name it. That's what that is. All right, I'm going to use a tool real quick. And you have to be very careful how you use this particular tool. But I'm going to use a tool real quick to kind of pick up this dust real quick. So give me a second. Not going to hear yourself think if I let this run while you guys are listening, so I'm going to pause it for a second. Okay, so we're back, and I was able to get the bulk of that dust compartmentalized and freed up. So now, what we're at the next point is we are going to go ahead and remove the last of the cabling, all but one thing. And the reason why I say one thing is because you want to take a little time and just look at it and identify that, okay, this is something you don't want to miss. And that is your power hookups. So I've got one here. And if I look at it, it is my hard drive LED. And my other one, which is a 2-prong, that's an LED. I know what those are. And then over here, I've got my power switch, right? And my reset switch. So those are important in the sense of what you're working with here. So now what we're going to do is we're going to adjust this just a hair so I can start to look at freeing up the back chassis. The back chassis is the power supply output, and that's the cabling and the power supply, as well as the mounting brackets on the back. Now I use these wonderfully great big fat finger screws. Very good, easy on the hands, easy on the old guys, you know, because we're old. And actually it's just smarter. But now we're pulling the power supply out, and as you can see, it is a horse. Let me free up the camera here. It is a horse. And I'll clean that up before you put it to use. And that is the first item, actually, I do put into a case, is the inspection and the configuration of the power supply. Because it's always the power supply that gets you, by the way. Just in case you didn't know that. Very true. Almost every time. Okay, now what we're doing is we're pulling out our thermostat unit. There we go. So now the thermostat unit is out. And so there's the thermostat, there are the fan controllers, there's the memory, there's the USB and the audio out and all that. So we'll put that over here, the fan, and it needs to be cleaned up. So now everything that's left is basically case only. So these power jack outputs, for instance, here are those, right? And check this. Yeah, that's also part of the second media unit, which I can no longer use. There it is right there. That's going to get retired. And so now all I have left is the motherboard. Now, this particular chassis does something really cool. And I'll miss this, but it's really cool. Let me show you. Isn't that cool? Basically, in a nutshell, the whole subassembly can hinge right out. So, since it's freed, I can actually take this out if I wanted to. Let's see, I should be able to. Except for one thing, I think I messed up. Let me get it here real quick. Yeah. There it is. Pretty nice. Terribly efficient to work on. And no, unfortunately, I don't get the joy of you having a fold-out door like I had before on this kind of chassis, because the nature of this particular design was to very easily depopulate and repopulate on demand. And hence the problem, right? So with that being the case, what we have to do next is we're going to go ahead and take the master screws of this out. Make sure we don't lose our front panel here, because that has to transfer to the new case. And this will free up this chassis and we'll be done with it. So this is where the long neck becomes valuable, because you can just reach in there. Sorry about that. You can just reach in there and just unscrew these screws. And depopulate all the anchoring points. Alright, so the bus board is gone. You have to pop out your I/O. You'll need that for later. You take this and set this aside. So, now you're in the clear. Now what you want to probably do while you have the chance is you want to clean this up some. Now my motherboard is actually pretty nicely clean. That's good. It does need some help. I've got some build up here. If you look on the front, you'll see there's some build up here. So I will help loosen that up right now and just kind of clean this up so that we can get ourselves in a fairly good place for our next step. And so I'm going to go ahead and pop the restrainer locks off the CPU fans. Very easy to take off. Very intelligent way of doing it, by the way. And I'm going to remove the fans so they can be properly cleaned with a brush. And so I am not interested in depopulating the heat sinks unless I want to repopulate the thermal paste underneath these, which I will do that in this. So you will see that happen. And that will be kind of a trick, actually. But I'll show you how that's done. All right, so first we'll take these guys off. And they're spring loaded, so be careful. But this does make it easier to work on these heat sinks by freeing them up correctly. Now I can already tell that the paste it should be replaced. If you look at it, you've got what's called a sheen effect, or it looks like thin pieces of paper. That means the thermal paste is pretty much spent. So that means I'm going to have to clean this up and get that in a good place. Let's see how much the other one is. Okay, again, you see how that looks like slivers of paper? That means that you probably could stand to reapply thermal paste to this so it's in a good shape. So hang on a second. Now you may feel tempted to clean these right here and now. Don't do that. That is a mistake. What you're going to have to do is you're going to have to depopulate your bays, okay, to get the processors out and separate them from the motherboard. Why? Well, because the cleaning compounds you're going to need to clean these processors, they can be kind of corrosive and they have an effect. Secondly, you have very fine little pins in this equation and you do not want to mess those up. So I've taken the restrictor bolts. These are the restrictor bolts that hold the foundation down. I took those off so I can expose the release locks and be able to free up this processor. So what I'm going to do is I'm going to transfer the CPUs off the chassis, move the motherboard over to the side, and then I will have just the processors here with my cleaners, and then I'll do the cleaning and I'll shave everything off and get everything cleaned up, and I'll show you how to do that. Every year or two I do this, and it's pretty consistently the same, but at the same point in time it's important to be able to identify that. Plus you're going to find little things like pods of hair and stuff in there that it's good to identify it. So give me just a second here while I get my cleaning gear. Okay, so now that we're here, let's touch about what we have here. Well, the first thing we have is we have our number 1 and our number 2 cleaner. Our number 1 and our number 2 cleaners are designed specifically to remove a compound. Wait a minute a second here. I've got 2 clean number 2s. Let me get the other one real quick. Sorry. Okay, I apologize for that delay. All right, so we have what's called our number 1 Arctic clean and our Arctic number 2 clean. One is a dissolvent and one is a cleaner from the dissolvent. So if you also notice, I have what we call an ice or a label scraper, which has a razor on it. You use this for a reason. I'll explain it to you in a little bit. It helps speed up the process of cleaning the chips. Now, first thing you got to do is always prepare yourself. Thermal paste is considered carcinogenic. That means it could possibly cause cancer. So just don't screw with it. Protect yourself effectively. Plus, by wearing gloves, if you missed a spot, it's going to show up on your glove real quick. Secondly, don't go out to Harbor Freight and buy these god-awful Q-tips for this. Not good. Not a good idea. What you want instead are the basic Q-tips. The typical 2-headed Q-tips. They are the best for this kind of work. Why? Because they're small, very small, so you can focus where you want the solvent to work and where you don't want it to work. So with that being made clear, then what you do is you have yourself paper tissues. Now remember, we are statically discharged, so we don't have a problem with static. So it's okay to have them and use them. You just have to use them carefully. Now I'm going to go ahead and take these restrictor bolts off on the second processor. And unfortunately, they're kind of loose, which bugs me a little bit, but I'll have to fix that later. So again, I'm taking the restrictor bolt off and taking the other restrictor bolt off. There were two restrictors that were holding each of these in place. Now I can get access to the release locks. So I want to release my first lock, then release my second lock. Releasing the second lock clears the first one so that it can lift up and clear. Now with that being done, your next goal is to carefully lift the processor off, making sure that none of the paste in any way, shape, or form makes contact with the unit. And check your gloves, because when you check your gloves, it's going to be able to tell you, oh, okay, I didn't bring over any thermal paste, so I should be good to go. So I'm releasing my first lock here now, and my second lock again. This second lock holds the plate lock. That's this thing right here. And it is designed to protect and keep the pressure even on the processor. And as you can see, the pins are now exposed. So this is where things get very dangerous for the motherboard. Those of us who know about pins know that we don't want them exposed. If you have what we call it socket guards, please use them. Now, so to give you an idea of some important information that can cause a problem for a Xeon motherboard, here it is. If you look on the sides of these memory sticks, you see the dust buildup? See that? And not only that, it's actually carrying over into the PCIe slots as well. So we're going to have to do a little TLC on the motherboard to clean up all that dust. But for now, we're just focused on these two guys right here. Thing 1 and thing 2. So the first thing we're going to do is we're going to take our number 1 solution. And before we're going to apply it, we want to try to get as much of this gunk off, right? So what I usually do is I'll use this knife and I gently take it across the surface area. See that? Now, the tissue will take it off for you and keep your razor clean. Then you can go back again and just keep taking all that excess dried out paste off. And as you can see, I'm very carefully using my razor, trying to get all the floating paste, all the old stuff off. Now the end result is you're going to have a fairly clean processor. And you'll be able to pick up on its side and continue to keep cleaning it up until it's fairly manageable and ready to be used. Now, my glove just made contact with some thermal paste. So first I'll clean my knife, put that over there, and I'll double check to make sure I have no paste. Nope, no paste. So my first processor is pretty clean. For the most part, it's ready now for a solvent. So we're going to do the same thing for this guy. He's a little messier, if you want to see what it looks like. He's got a lot more gunk on him. And this is just dried thermal paste. So we'll take all this off as much as we can. Now I've seen people do things with their processors to maximize their heat transfers. Unfortunately, it's a great idea, but it really doesn't work. Not like they think it does. And that's unfortunate because the reality of the fact is that when you're working with these environments, for the most part, they're pretty much optimized already when it comes to cooling and keeping it all in check. So, all right, so we've got ourselves in a good place. Sorry, I don't want to sneeze, so I'm going to blow my nose to keep that from happening. Now, what you want to do next is you want to check the other side, and there it is. You see that? There is thermal paste there. So we have to make sure that we get all of that off. None of it can be there. And it just literally has to be completely clean. Okay, that's good. And we'll do the same with the other one. That one is clean. So that's good. I hate it when it gets stuff on my chip. That's not good. All right, so now thoroughly clean your surface area. And by cleaning your surface area, you're going to make it very easy to clean the unit. And then here we're going to put our units here. And we're going to go ahead and we're going to put a few drops. About 3 drops is all you need. Xeon processors are large, larger than i7s and so on, but you're still pretty much, doesn't need a lot to clean it and get it to the point where you can read the name of the processor on the CPU, because it isn't laser etched on the top of the CPU. So we're just going to give this a second to kind of dissolve the cohesiveness of the thermal paste. And as you all know, or you may not know, the metal complement on top of the CPU is a thermoelectrodiode, or a TED. What is that? Well, basically it's a heat pump, except it's for a processor, not for like your air conditioning. It is basically designed to take, by using electricity, heat from one side and conducting it to the other side. And that dumps it into the heatsink, which is this guy right here. And then this guy uses what's called convection effect of hot versus cold gases to transition the heat from the TED, which is this metal plate you see here, into the heatsink so the heatsink can get rid of the heat. And that's how it works, over and over and over. Now, we're going to take a tissue and we're just going to clean things up here. All right. That one cleaned up nicely. And we're going to do the same thing for its brother. I usually wad it up in a centerpiece. Again, your goal is not to let any of this stuff get into the actual logic of the processor, the green part of it, if you want to call it that. And then what you have is a completely dissolved surface. And now you can see the name of the Xeon processor, its release date, and all of that. Now check your gloves, and if you have thermal paste on your gloves, remove them if you have to, if they don't clean up well. That's an important detail. They've got to clean up. If they don't clean up well, you got to get new gloves. And again, you need to check the bottom. Make sure there's nothing making contact with those base pins on the bottom. Okay, still looking good. Now I'm going to take that blob of paste and get rid of it. I'm not too anal about, cleaning up all the paste, because the reality is you're just going to put new paste down. So I'm going to go ahead and throw this away and get new gloves, because my current gloves are no good. All right. we've cleaned off the CPUs, and we are putting on our gloves again. Things get a lot easier after this, by the way. Now what we're going to do is we're going to use our number 2. The number 2 is basically designed to get rid of the solvent that was used by number 1, because it can stay around. This kind of cleans up the board. Think of it like a window cleaner of sorts, making the surface primed for something sticky. And in this case, that sticky would be our thermal paste, per se. So now we're spreading this out. It'll actually give it a little bit of a shine because it's really clean. But unlike its number 1 component, this isn't designed to get rid of the gunk. This is designed to get rid of the solvent. So I'll put that over there. I'll give it a minute. Meanwhile, I'll secure my knife. And I think we're ready. So we will now go ahead and give her a good rubbing. Don't do it hard. Nice and easy. There's nothing ever that should be done hard on these machines for any reason. If somebody does something hard to them, it's because they're angry at them, which I can see. All right, so now I'm looking really clean. Everything looks, for the most part, good. We want to make sure that we have no accreted liquid on the processors. Very important detail. All right. So now our CPUs are ready. So I'll put them over here for now. I'm going to bring this guy back over. And we're going to use our inert gas compound. Just to get the dust. Get your finger over them. That helps loosen the dust. Clean out your power feeds. Work on the heat sinks. Make sure they're in the clear. It looks good. Now get your PCI slots. They do get kind of yucky over time. You notice that I'm doing short little bursts, and the reason why I'm doing short little bursts is because if you just hold this down, you'll lose pressure inside the can because you've decoupleized the liquid so quickly that it can't repopulate the can with pressure. That's why these cans work like they do, and they get cold, just like a heat pump does. When you start transitioning from a liquid to a gas, it starts to absorb the temperature around it, and you don't have a functional pressure source to push the air out. So therefore you can no longer get the air you want out. So now what we're going to do is we're going to put the processors back in. They only go in one way, and they will flop right into place if you do it the right way. Now you can close it like this, put your primary lock down. That is now secure. And then this is used to keep the pressure equal on both sides of the clamp. Don't ever not do this completely, because you can have a big problem if you do that. So here we are doing the same thing here. There, just flopped right into place. Then you go ahead and drop your bracket down, lock it in, you're done. This is now set up. Now stand by for a second while I prepare the heat sinks real quick. I'm gonna take my gloves off. I'll be right back. Okay, so now we have the heat sinks. Now as you can see, the heat sinks have a similar kind of setup as the CPUs do, because this is the other half of the contact. This is your transfer points. So again, we're going to take our trusty little knife here and a tissue, and we use the tissue to catch the gunk that comes off. But you can just basically rub it off like that, and then go over here and do the same with the other one, and it comes off pretty easy. Now, I wasn't kidding you when I said this stuff is really sticky. So now I have to go and wash my hands real quick. So give me a second while I go wash my hands, because I forgot to put my gloves on. Okay. So my hands are clean again. Well, I don't know why I did that, I just did it. But anyways, getting my gloves back on. Alright. So as you can look at these, they're not clean, but they're getting there. So again, we're going to be using the number 1 solvent. 3 drops. 3 drops. Our Q-tips, which will make sure we're getting rid of all of the old paste. It's an important detail because it will inhibit, it'll act kind of like an insulator. And that inhibits heat conductivity from processor to heatsink. So you don't have to wait much, very long. You just have to put it on there, let it loosen up the debris, and then boom. Now look at that, much better. Now again, number 2, and that's to get rid of the solvent. 3 drops usually does the trick. And you're going to move around. Make sure it's breaking it all down. You might have some edges on it. You might have a little bit of the compound on it. Just wipe it down. Again, it only takes about 30 seconds. And then at that point stage, you can now go ahead and clean off your heatsink. And now there's a kind of a rainbow effect on the metal because it's polished. It's pretty impressive how this really gets everything off of the metal and exposes the metal. So now, if you look at it, it's just like a mirror. Quite an improvement. Again, a mirror. So, obviously, if you look on the sideline, it's still kind of yucky, right? And if you look in between, you'll see the dust build up there. So the first thing you want to do to deal with that is you want to turn them downwards like this toward the ground. Now I'm going to do this on the side, but I'll give you a narrative of it. So the reason why you point it down is because that was the direction the dust built up from. Which means if I blow it from the place that doesn't have dust, it surprisingly comes right off. Now, if you had flipped it over and tried to clean the dust off from the dusty side, you'd be shoving the dust through the blades. And just by that little bit of work I did, look at that. Much better improvement. Now, you then can take something like a napkin or a tissue, and you can just get the last of the dust. You don't have to get it completely. You just have to rub it. If you rub it, it loosens the dust, and then the air intake will be able to free it up completely and send it on its way. So this is a done and clean versus a dirty, not clean, and like look in the middle there, it's pretty yucky, right? So I'm going to turn this guy, and I'm going to finish this guy next and get him done. So with just that little bit of work, it's clean again. Again, I will take a tissue just to loosen anything up that still might be around. Because that's how dust works, by the way. It's attracted. And trust me, a paper tissue, it loves tissues. Dust will gravitate to a tissue like you wouldn't believe. And the end result is you have a nice, ready to go, brand spanking new heatsink, ready to do its job. Now, for those who don't know, this is a gas 1, gas 2 style device. It is very much like a heat pump. It basically takes air intake, it transfers hot gases inside the actual cooling area here, which will then in turn back into a liquid and drop to the bottom where the heatsink is and turn back into gas and back up, and it rinse and repeat process. That's called a heat pump. You're pumping it out. Now, heat pumping can happen naturally, but we also use what we call TEDs, thermoelectric diodes, to facilitate it. And if you know of an air conditioning system, you would know that an air conditioning system that works on the principle of a heat pump, like I have at my house, does pretty decently in middle temperature environments. With the TED support component to it, it's pretty awesome. It's pretty productive for what I want it to do. But in this case, it's a value add to keep these processors cool, because the cooler they are, the better they perform. So the next thing I have is the fans. Now these are high quality fans. Always recommend that you use high quality fans. Don't go cheap on your CPU fan. These are HM120s. Really great overall style fans. Very well rated. They just don't stop. They just keep going. I'm really impressed with them. Believe it or not, an Intel based heatsink is actually a pretty good fan too. It's just specifically spec'd to the nature of the processor it's supporting, and that is it. So with that being the case, yeah, it's important to understand that when you're working with that, moving Intel fans from one processor to the next, it really genuinely needs to be the correct identical type class processor, or you could be providing an underpowered fan for something that needs a lot more cooling. And that happens a lot because the fan fits, right? Just because a fan fits a hookup, or you can span it to a heatsink, doesn't mean that the fan is properly rated for your CPU. Remember that. So now what we're going to do is we're going to put our fans back on. Well, actually, we won't do that yet. My bad. All right, let me get my other fan here prepped. All right, we've almost got this done. We'll go ahead and here. Apparently this one has cobwebs on it. Actually, they're not cobwebs. It's strung dust. It's something that happens at the edges of the blades that kind of forms a pseudo-strong line or a ridge line. And then over time, it becomes stringy. So you end up blowing long strings of dust or woven dust into your system. and you don't know why that's happening, and that's the reason why it's happening. All right, so the fans are done. The CPUs are ready. The heat sinks are ready. So what we're going to do is we're going to pull these off to the side, and we are going to put the main board back. Here is our main board. We're going to restore it to its proper configuration. And we're going to remove some other things off the table here. We're going to need our restrictors. There they are. And we'll put that here. Then we'll put this one. Let's see, yeah, that's right. That one there. Put this one here. Now these are, if you look at these, they're actually set with distance headers on them. So in other words, you know, depending on where you have to have them, you want to make sure that you have them in the right place. So I think, in this case, that's wrong. That's wrong. Okay, so they're on the wrong way. All right, all right. And my other one's off too. So what do I mean by them off? Well, if you look, they should form an X between them with the inline spacer for the processor. So both of them show that, and that means when I bring the heatsink over correctly and I put it onto its base, it's going to sit correctly on the base, like that. Now, you want to make sure you get it right before you put your locking bolts on. And these are bolts, these are not screws. They actually go down on the surface and they pinch this unit in place so it doesn't go anywhere. I'll show you what I'm talking about. This is basically a nut, and it's to be threaded onto a threaded shaft, in this case the inhibitor locks that are holding the restrictors in place. The restrictors are specifically supposed to keep it from moving, because when you put this down in place, you have springs that generate a lot of pressure. And so to get them in the right place, you have to make sure these guys are in and with the proper screwdriver secured. They don't always get secured, and yes, believe it or not, because you're dealing with heat and cold, they will unscrew themselves. So it's important that they're tight. Now, I have not put the thermal paste on yet, because right now I'm just making sure that I can correctly space these right and that they'll lock. Okay, it looks like they'll lock. All right, so let's do the second one. Make sure he'll lock. He's not changing either. So let's go ahead and put that on. Yeah. Now, if your extenders are on backwards that support the restrictors, they'll reach out and touch your memory. You don't want that. Nope. You do not want that, because then you run the risk of blowing the motherboard. Because on each of those chips, there's small little metal contacts, and you don't know what can happen between that contact and the voltage load on the motherboard. Everything has a home, and everything has a place on a logic board. So again, let's make sure this one's tight. So I don't think it was. It wasn't. Okay. Again, you want to put your, make sure everything is good. All right, so that's good. Let me go get the paste. Okay, so I'm using an Arctic style kind of thermal paste. The thermal paste is MX4. You can see up there, right? See? MX4. It's a good standardized and stays fairly liquid. That's the problem with most thermal pastes, is they eventually become paper, or they basically get dehydrated. And so you have to make sure that you periodically check on it to make that it's not too dried out, because if it is, then it's not doing its job. Now I put about a dime size head in the middle, and it does not have to be perfect. No such thing as that. And then we will put our placement, our first screw basically, and then we will get our second one in place. And what you want to do when you're putting a spring-loaded heatsink in, you want to evenly screw the screws in. So once you get one threaded, turn it 3 times, then go to the other side and turn it 3 times once it's threaded. And you just keep repeating the process 6 times each time, until the bolts stop screwing. And you just keep going back and forth until the heatsink is fully in place. Now don't worry about that, because once the threading has hit its proper placement, it will just simply stop. That's about 6 turns. Okay, now I've got that heatsink on and it's secure, so I'm going to put the next one on. Now the very important detail also to remember is when you're doing this and it's floating, thread your first one by hand. That's going to be the easiest threading you'll do tonight. After that, then it's you pushing down with a screwdriver against a spring to lock the other one into place and thread it. That's just part of the game, unfortunately. Let's see, did it take 4, 5, 6? 1, 2, 3, 4, 5, 6. Okay, we're good. So now our unit is in a good place. And then what we're going to do next is we're going to reattach our fans. Now, as a reminder, remember that the gripping effect of these fans can be a little weird. But eventually you'll get them to fit. It's just weird, that's all. All right, so they got to sleeve in and lock into place inside the heatsink itself. So as I put this one on, I'll show you what I mean. Well, I guess I can't really show you, but there's a sleeve point inside between the two cooling coils, the inside and the outside. These lock right in the middle between them, holding the fans securely. And there's a white strip on the inside of the heatsink that's designed to prevent cavitation, or basically, what would you call, I would say, like a rubbing effect. And you always want to make sure that that rubbing effect is never an issue, because that can cause bigger issues down the road, right? Now I'm putting these two CPUs power outputs back in place. And what I'm going to do now is I'm going to take my collective gloves off because I'm done and I have no hazardous material to work with right now, which is a good thing. And I am going to get a magnifying lens to zoom in to make sure that these proper hookups are right and that they're in the right places, because I have fans. I have a fan output here, I have a fan output here, and so on and so on. Oh, and I've got them over here too. I want to make sure that the proper outputs are in the right places. Now you need a magnifying glass and a flashlight. So I've got both here. I've got glasses that are really super high powerful glasses right here. And I'll put them on. Man, I'm blind. Okay, so I'm looking at these and I wanted to make sure that, you know, that these fans and these IDs are the correct fans that I need to be plugging up to. Those are fans. All right. Fan 1. You'd think they'd call fans what they need to be called, right? Right. All right. HD audio. Interesting. Truly interesting, because according to this, I don't have a designate. I have a fan alpha, a fan 4. I just noticed this. This one is fan 3. That's fan 2. So you're fan 1, which means, that's an issue. I didn't have these fans on right. That's disturbing. All right, so fan 1 is there. And you belong there. All right, so that's good. All right, good news. Please. Had me worried for a second. See, it's very important to double check all of your wire connections because you never know when one isn't right. So that's an important detail. So with that, we are now ready to bring over the case, the new case, and prepare for the power supply first, and then secondly, the motherboard second. Everything else will be secondary, and I will not be putting my peripheral devices in until last because of the convolution effect of how they're designed. The SATA hard drive chassis generate a lot of power requirements and SATA power connectors and so on and so on. So I want to be kind of careful how I go about doing that. And so I want to make sure that that'll work out. Because I only have room for 2 slots. So I might just go with the dual drive and the Blu-ray and then the thermal couple sensor. And then that should give us, I think, what we want to do going forward. Now what I'm going to also have to do is I'm going to have to temporarily take my pivot door on my case off because it is tempered glass, and that means technically it could break. So I don't want to break anything, right? I want to make sure everything works right in that capacity. So for now, we're going to move the motherboard off to the side and prepare for, staging the case. So on the case side of things, I can take these guys, I can take the door off. All right, so that's good news. I really want to be careful how I do this because I really don't want to drop my sheath of glass into the ground. So stand by here a second. I'll shift this around for you to see. All right. So I'm going to leave one screw in there because I don't trust it. It doesn't look like they're bolted. That's good. Take that part. All right, so now basically, mostly it's free. So if I release this bolt, I take this guy off, I should. There's one. Come on. All right, we have the glass off now. So I'll put this over here to keep it safe. Oh, the glass is bigger than my old tower. Right, now I'm not sure why this guy did not come off, but I don't want him to, I don't want to lose the screws. So I'm going to put them back on. Trust me. When you have specialized screws, you don't want to lose them. No, you do not. Okay, now the other one, the other hinge assembly came off just fine, which is kind of weird. So I'm going to put that one back on as well because now I know that these are pivoted on the pin. I don't have to take these off in the future. I can just wiggle the door off the hinge. So that's good. And I think I know why that top one won't come off. Because the threaded section is expanded into it and now locking it into place. Huh. That means they used too soft of a metal for the frame. That's an important detail to remember. Okay, so some of the things you can do automatically, like for instance, you can take your I/O bus interface plug up and you can put that in just to get that out of the way. Shouldn't take too much to get it in place. Yeah. And it's in. So now we've got our I/O bus board in. And for all of our ability to slip the motherboard in effectively, should be good. Now our next goal is to put this, let's see here, first things first. You have a lot of interface connections in the back section that, excuse me, that you're going to need to prepare. These can't stay over in this section because if they do, they will be difficult to put in in the right places as you need them. So with that being the case, looking here, 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 and here, right? Right. Right. Huh. That's interesting. Okay. So I'm freeing up the cables I'm going to need for connectivity to motherboard CPU fan. Huh. Interesting. It wants to power off the motherboard fan, huh? Interesting too. Alright. Alright. Alright, so I'm freeing up my interface cables so that I can begin to use them. And so pulling them out, let's see all these wires here. See those right there? These will have to be kind of re-synchronized with the setup you've got here. And you also want to make sure, though, as you're working with your Velcro straps, make sure that you're keeping the remaining fan cables secured for now. You'll bring them in when you need them. But for now, it's strictly just a process. Okay. So I've freed up the cables, and that means now I can go ahead and begin the process of mounting the power supply and then eventually the motherboard. So the power supply will go down here. So I'm going to adjust that out so you can see it better. There you go. Power supply will go here. And it has a interjection section, which is covered with the metal frame. So my question is going to be, okay, on the frame side, how safely should I go about mounting this power supply? And so it looks like the best way to do that would be to release the lock suppression screws that are right here. Okay, now this particular design is specifically geared for isolating the heat of the power supply and funneling the power supply right here. Let me show you. Funneling the power supply through the bottom of, for the intake here at this side, which means the power supply I have, this one right here, will actually technically be upside down. It'll be like that. So that's a little bit of an issue, but I can make it work. That's not going to be a problem. So I've taken up those two primary screws. I've got another set of, yeah, I do. Two more. Okay, hang on. Should have felt that. I didn't. Yeah, let me put that. Okay, now that was not a good idea. How they did that. Not a good design, guys. Sorry. The reason why it's not a good design is because you can't get a screwdriver in there. Which means unless you have a specialty bit, which I do happen to have, that would be this guy right here, you're not getting in there. And you know what? I still might not be able to get in. No, I might not. Nope, I can't get in. Really? That's just a pain in the rear end. Huh. I got one off. What a pain. Let's see if I can get this one off. Yeah, they should not have put this here. I would have just used 3 screws. 2 upper and 1 lower. Would have been enough, in my opinion. But it's out now. Okay, so flipping the unit back around. Let's see, looks like we got 2 more here. Restriction bolts. Way too many bolts for this. Why on God's earth did they do this? I have no idea. That is overkill. Ah, there it is. Okay, so now we can do it. Man. All right. There's the shield. Don't know if I like that, but that's okay. I get why they did it, and if this was a water-cooled system, that'd be fine. Matter of fact, it's actually a good idea because it actually acts as a dual shielding effect. That would be a good thing. Okay, so let me get this going. We are placing the power supply into its home. I'm going to get that mounted first. All right. And like I said, I use these very large thumb screws because it's just so much easier than using a screwdriver. You know what I mean? So I'll get these mounted. There's one. There's 2. There's 3. And then there's 4. All right. My airflow circulation is right there. I'll put this guy back on. So that completes the base of the power supply area. We'll look at it here. We've got the air filter in place. We've got the power supply locked into place. And now what we have is our output port. And this is going to be, this is why I'm not going to put the shield on. Because if I put the shield back on, as follows, like this, I'll have to battle the cable feed, and it's right against the glass. So I don't like that idea necessarily, but we'll work with that last once we get the rest of this in play. So now our next challenge is displacing all the cabling feeds back underneath the board. so that this motherboard is nice and flat. Now this baseboard config is the actual mounting config set for your screw mounts. So what we have to do here is we have to look at our mounts that we have and make sure that, okay. So I have some problems. The mounting stems for the actual motherboard are not correct. So I've got to take one out, and I have what's called a freestanding. It's basically a standoff designed to act like a screw mount. But I'm going to take this one out, so I don't run the risk of shorting out the motherboard. It's basically a hex config nut. And you want to do that. All of your standoffs that you have for your motherboard, you have to measure them and make sure that they are not in the wrong place. If they are in the wrong place, the end result is that you will have a pretty serious problem with your ability to be able to keep the motherboard safe and secure. So standoffs don't like to come out very easily. That's because they have to do a lot. But this is a standoff. If you can look there, you can see it's basically a hex nut style setup that takes a screw on the top. So you're going to have to go through and make sure each screw alignment of the motherboard matches a standoff that is in the right place. Yes, yes, yes. What's in the middle? Something in the middle. I don't have anything in the middle. That's not good. Nope. Alright, so the middle one's got to come out, but the back one can stay. Alright, so we'll take that one out. This is very normal. This is nothing too stupendous of a surprise. Motherboard companies will sometimes fully populate all the standoffs and just leave it up to a professional to properly build the case correctly to get what needs to be done. So I have 3 standoffs here that are not supportable. Right, so that means this middle one is no good either. He's going to come out. Now, a lot of people sometimes will put in buffers or standoffs that have no screwing, and they're made of plastic or rubber. And they do that because they don't like the fact that the middle of the motherboard is not supported. I wouldn't worry about that, to be honest with you. But your only concern really is to make sure that the screws that you used before will work on the new standoffs as well. They may not. So the easiest way to find out is just take one of the standoffs out and thread it to confirm. If it doesn't, that's okay, because I have a whole new box of stuff that came with it right here, and these should work. Just need to identify which ones are the correct ones for the standoffs, which I suspect is this. Yep, that's it. Huh, black screws. That's okay. And that doesn't bother me. All right. So these are the screws we're going to use. to mount this. These are second tier screws, basically. If you follow PC terminology, second tiers are the second smallest ones. Usually work best for CD-ROM drives, mounting drives, stuff like that. But in this case, it's going to have to work for the system, right? Okay, so now I'm going to take the motherboard and make sure that all the standoffs matches. Right. 2 and 2, 2 and 2. Right. Any others? Any others? No. No others. Okay. All right. So now, once you get your unit in, I've got a nice little, really awesome flashlight that does a great job at sticking in places and giving you light so you can do what you need to do. Does a really good job of it, actually. Okay, it looks like that's aligned. Are you aligned? Nope. You will be. All right, you're aligned. Okay. Now, now we're mounting the screws in. Don't put them in tight until you know everything's going to fit right. And remember, again, with standoffs, don't force your screws into place. If the screw is not the correct screw, which is always a possibility, you will know it pretty quickly. Don't force it. Or you de-thread the standoff and then you've got real problems. Problems you don't really want to deal with, right? So far though, all of my standoffs are going in pretty good. I'm not complaining too much. Except for this one. This one's pivoting. Why is he pivoting? There you go. That's better. Yeah. It doesn't want to go in right. There you go. Sometimes it's surgery. Sometimes it's not. All right. That is done. Now, I use an open-ended architecture and I don't stress out my platforms because I want them to last a long time. And this one right now has lasted 6 years, with still another 3 to 4 more years of life on it. Systems are becoming more like that as really sound people who know how to get these up and running do them. So with that being said, of course, you have to make sure that you're getting it all set up the right way so that you don't have to go back twice. So go over each of your interfaces, your screw standoffs, and everything you do twice to make sure that you've got it right. Now, with that being done, I could technically go ahead and just do the standard template footprinting of the system, put my card in, put my feet in, all that good stuff in to get it to do what I want it to do. But right now, that's easier said than done. So what I'm going to do for now is I'm going to go ahead and put the power feed in. and make sure that all of my outputs are correct and that they are doing what they're supposed to do. Now, with that being said, I also have to make sure that my support and connection, I'll take that off, are good to go as well. So here I have my PCI out and I have my power, which are these guys right here. These are my PCIEs, but this is not. This is a different type of class connector. And I have basically everything prepped correctly so that I can go ahead and now move to installing my NVMe card. Now what I'm going to do also is I'm going to set up some visibility inside here. Make sure I can see what I need to see. Now in the back of this chassis, everything is vented, including the sleeves. I'm pulling a sleeve out now. This is a no bracket sleeve. I'm going to pull that guy out. I'm going to put my very important card in. It's a little on the free side. Hope that's in there well. All right. Go ahead and securing that down. I've been told not to cut out this kind of work because some of you guys like to see the real nature of the work that needs to be done, because it really genuinely tells you the truth of doing something. I know a lot of people who make videos make it in such a way where it looks easy, quick and fast. Why? Because they want you to be successful. I get it. But the truth of the matter is, to do anything right, you have to take the time to set aside that planned work and effort and to get it right correctly the first time. And by getting it done right the first time means you're going to be able to have a good solution that's going to do what you want. Oh, shoot, that wasn't good. That was not good at all. These screws they provide me are not magnetic. That sucks. I don't like that at all. Though I understand why they're doing what they're doing, it's just not making it easy. You gotta do it by hand. And that isn't going to work very well. If they were going to go this route, they should have gone with a toolless lock instead of the threaded screw, because these guys won't lock down correctly as they are, and then they fall right off down into the chassis. And so if I switch over to a magnetized screw, it should work just fine. Yep, look at that. First try. That's alright. I'd rather my video card be secure than to have a fancy screw that doesn't do what I need to do. Oh, come on. There it goes. Well, that was a pain in the butt. Okay, So I don't expect to be using any more than a single GPU going forward. So that means I can lose one of my PCI slots or PCI cables. But at the same point in time, I also need a PCI output for my motherboard. So I'm going to hook that up. Alright, I'll just leave that there for now. Okay. And then I'll take one of my PCIs, which is a dually, and that's precisely what I need is a dually. A dually is basically a dual-headed PCI head cable, capable of supporting 2 video hookups, and in this case for 1 card, which is my card, and that will take care of the power output requirements. Okay, good. I have junction feed power cables, right? All right. Right. So, if you look in here, you will see that the environment is pretty much set up. The shielding is not there. You notice that my SATA cables are pretty much useless down there. That's a problem for me, of course. If I'm going to use my SATA cables, I'm going to have to figure that one out, which means I may not be able to use my CD-ROM drive. That's because the only PCI 16 is in the middle of the board, not above or below. So it has to be done that way. With that being said, I've got my outputs up there for my power feed. Power for the motherboard is in place. And I'll change gears here for a second. Now, the other important detail I'm going to have to do is I'll have to remove the GPU board to prepare my power feed cables so I can power this unit up. That should not be a problem. I know where they are and I know where they go. The only challenge with this one is I only have a single button, not a dual button. So I'll have to figure that one out separately by reading the manual. But at this point in stage, so far we've done a pretty good job of displacing the original setup, which we have in here. I got out of the old case, we're in the new case now, and we were able to principally get the motherboard in snugly. We'll take the GPU out again, just because of the fact that I have to get some cabling in there to properly align it. Excuse me. Tickle. Anyways, so we'll pull those out now. I'll get the motherboard in there. Okay, now we're going to go ahead and pull this guy out. The bad boy is out. Alright, so these are my power plug-up connectors. This case has a single power button. My old case had 2 power buttons, one to reset and one to power. So I'll have to feed those out separately to get them in the right place, get them connected. That way I can begin the process of testing and getting that running. The other key thing that's important here is that my USB 3.0 is here as well, which is also another connection I've got to put through, and my SATA bridge connection, which I need to have, And I got two exterior outbounds as well as interiors. So what I can do is I can take a lateral head like this and put it in, and that will allow me to get under the GPU. Sorry, wrong way. So I want this one to be here, and that will give me one SATA connection safely. I have other connections which I need to run too, and that's going to be a little bit of a challenge. So what I might do is instead I might just move this down here. There it is. Run that up through the chassis up to the base so I can get the connectivity I need. So with that being the case, I need to get that power setup done next. So that will be going around the other side. Identifying the cable feed outs that I need. Which this cable is right here. Alright, so the first one I've got is not usable. That's for an advanced connection that I don't have. So I can leave that one behind. And the next ones are, let's see here. I have a LED right here, and I've got a reset switch right here. I have a standard USB output right here, and I have a 3.0 USB output. Now this guy, he's going to go down below, maybe here, maybe better, and then this one will go here. Let me check here. All right, going back over here. I'll pull this down a little bit so you can see. Now what I'm doing right now is, remember I told you about the issue about hooking up certain things like USB and so on? Because they're going to be directly in violation of the video card. Which means the video card will be distressed, unfortunately. So with that being said, the audio, okay, where's audio? There's audio, way over there. That's not cool. Okay, let me pull that out over here. Bring audio through here. Correct. Yes. Yes, and yes, and yes. Those are all good. So what I've done here is I have placed basically the 3.0 here, the audio here, the SATA, the only SATA I can really get to use right here. The GPU is going to have to go on top of those, and I'm going to lose all these ports due to the GPU because it's hanging over. It's a thick chassis. I mean, it's a really thick platform. I might choose to take the heatsink covers off of it, but I don't want to do that unless I have to. But here's where the card sits. And I can't take it to this guy because he's not the right kind of port for it, unfortunately. And then that causes a complication for this NVMe card because it needs to be in the first bus. So you have a little bit of a game you got to play with that in the configuration. So what I'm doing here is I'm trying to get all the pre-configuration requirements done so that I can put the video card back in and get this to the bootable post state, which is what I want to do next, and that is post the operating system, see if it comes up, make sure everything's connected correctly, and so on and so on. Once that's done, then I will turn around and start putting it back together completely for all the devices that which need to get support. So in regards to that, I'm looking at doing this guy, which is a CD-ROM drive and only two SATAs. And that's good because this chassis, this tower is not designed for 2.5 inch. It only has two 2.5 inch slots in it for mounting. And I'm not going to use them, frankly, because they don't do me any good. So what I'll do instead is I'll use this in its place and be able to use it in the chassis at a second time. Then I'll use the data I/O input unit, which is this guy, and my thermal control. Hit it quick. That'll be this one. But I'm now starting to guess if I really should or not. The reason why I'm saying that is because I feel like it's not going to be as much value as I was hoping it was going to be. So I think I might not do it. What I might do is just dual CD-ROMs with the two SATA disks and be done with it that way. And that will give me everything I really want, generally. The only other problem I have is the fact that I can't technically use my, let me look here. Yeah, I can't use, that sucks. So basically, in a nutshell, I can't technically use the SATA connectors yet. I'll probably have to put another SATA controller in so I could get connectivity to connect these two additional drives up. I have enough for the blue connector, right? So I can plug that up here. That's not a problem. It's just that I can't connect these two guys up correctly, which is, kind of a pain in the butt, but I'll figure that out later. That's not a problem. The most important thing is to understand that, your base config, your base fan, your CPU, your cooling, your power, your feed, your video output, all of that is lined up correctly. So that's what I'll do next. I have a fan distributor here, which I find very interesting. It seems to be like a common bus distributor. I showed it to you earlier. Let me show it to you again. If you look right here, you have one input here, and then you have a couple of fans that are connected up here, which will go up to here, and the other one which goes to the back. Now what they do is they run off of the primary. This is the primary right here, and it wants to plug in on a CPU fan, which I am not comfortable with. But I will take a look at that. I think I'd rather put it on an alternate fan setup than let it go on one of the core CPUs, because I have two CPUs. And that's the big problem here, is this was designed principally for a single CPU environment. So they weren't expecting you to have another unit available for use. So because of that, I have to reevaluate how I want to use that so that it will work right. So my next thing that I'll have to do is my LED and my power switch. Get those in place. Anything else missing? Everything else looks like it's right. Yes, that's right, that's right, that's right, that's right, that's right. This will not be used. So that will be used. So I'll reattach those. But I need this to go to one of the fans. Okay, so we'll do that. So now what I'm going to do is I'm going to attach the main CPU fan assembly to a motherboard fan output. Doing that now. And these are standard fan outputs, but they're going to power multiple fans in one home. All right. So I've got a reset switch. Right. Let me see if I got my glasses right. All right. So I've got that one in place. Now we'll do the LEDs. Oh, interesting. All right. That's going to have to change. That's going to have to go there. And that will have to go here. Hard drive LED. All right, so with this, I can now take a look to see if I want to put this back on, the heat shield from the power supply. And I think the answer is going to be maybe. So what does it look like now? I'll show you. So here we have the breakout. This is the shield. And it does keep that heat factor out of the equation. And that means your returns are coming through here, they're going to blow through here, and they're going to go out there. Right here is the return fan for that. So that actually gives quite a bit of flexibility. And if you look up, you'll see that there's also a perforated top as well for airflow. So that gives you a pretty viable footprint to work with for keeping it cool and keeping specific heat loads off of the motherboard. So with that being said, you'll find that as part of that configuration and heat load work, you know, are things going to get in the way or not? So far, I got to give it some credit. It's not going to be in the way. Not that I can see. I think the biggest problem is going to be what will be in my it will definitely be in my way will be the CPU card and its ability to keep out of the way and cause potential problems. So what I'm going to do here is this is part one. This is the build process that you're seeing here. And I'm going to continue to work this. I need to get the motherboard manual and double check these connections one last time before I begin to put the GPU in principally for the final time. I'm also going to look at how do I really want to deal with these SATA connections. I don't want to be completely without SATA. I want to be able to use it if I need it, but I don't need it for anything more than 2.5-inch drives. So I'm thinking what I'll do is I will go ahead and get some more L-style cables. These are These are not L-style cables. They don't go at 90-degree angles, and that's the problem. But I will get them, and I'll put them in along with a SATA bridge connector cable, which is not here. Okay, I'll have to deal with that separately. But all in all, I think this will work out pretty good. It's a lighter case, aluminum base, better heat distribution, has better control over the dust. That's my big headache right now. Just so much dust and the mess that's involved with that. And get my system up and running by tomorrow, so I can use it for work. Well, for now, this is Brad Dyke. There'll be a part 2 on this that will be coming up pretty quick. Not tonight, but tomorrow. And I might merge these into one, but right now we're going on 2 hours and 12 minutes. So I think what I'll do is I'll step away from this. This is one of my longer ones, but you know, when you're dealing with, you're transitioning from one environment to the next, I wanted to show it to you done right and done in the right format, because a lot of times we transfer crap to crap, and that's not necessary if you use what you've got smart. This is Brad Dyke signing off. God bless, and look for part 2. Thanks, bye.